In this video we're going to be simplifying square roots, starting off with rational and then moving into the irrational, and kind of focusing on the difference between simplifying versus solving. So a lot of times you'll see instructions that say simplify. For example, to simplify the square root of 25, we would simply say it's 5. But if we were asked to solve, let's say we had the square root of 25 equals x, and we're trying to solve for the possible values of x, well, there we need to say that x equals positive 5, because 5 times 5 is 25. But we also need to say negative 5, because negative 5 times negative 5 also gives us positive 25. So solving gives us a positive and a negative answer, and we can rewrite this in a simpler form. We use a plus or minus, or a positive or negative 5. And that lets us know that those are the two possible answers, the positive 5 and the negative 5. So that's kind of a fast way of describing the difference between simplifying and solving. Simplifying is just wanting that positive value. Solving for a variable using square roots is going to give us a positive and a negative value. Alright, so let's practice simplifying some square roots here. So that was an example of a rational square root. We just get a whole number. Let's do a couple more easy ones here. It's always nice if you just know squares right off the bat. If you know that 12 squared is 144, then the square root of 144 is 12. If you know your squares from 1 all the way up to 15, it makes life a lot easier. Again, square root of 225, that would be 15 squared, so the square root of 225 is 15. So if you know things like that, it makes life a lot easier. And it definitely makes simplifying irrational square roots a lot easier as well. So let's get into those. Those are a little trickier. So those examples we had where a whole number just pops out of the square root, it's called a perfect square or a perfect root. Examples like, let's see, the square root of 12 though. 12 is not a perfect square, so its root is not just a whole number. We got to simplify. And there's a couple rules to go along with square root math. One is that any number under a radical multiplied by another number under a radical, we can rewrite as just putting them both under that same radical. So we would get a times b under one radical. So I can break this one up into factors here, factors of 12. So I could say that that is equal to square root of 3 times square root of 4. That gives me the square root of 3 times 4, right? You can always go backwards. You could start, you could break this down to 3 times 4 under one radical and then break it up into two radicals. Either way is helpful. So now we get the square root of 4. Well, that's easy to do. That's just 2. So what we do is we take out the square root of 4. That just leaves us with 2, but we still got square root of 3 there. We cannot multiply numbers outside of a square root by numbers under a square root. So we have to just rewrite this with this whole number first, and we just attach what's left, the square root of 3, right next to it. So this is our final simplified irrational solution right here. Alright, let's do another one. Here's another rule of square roots. Anytime we have fractions, so let's say we got the square root of, let's keep it simple first, of 1/4. Well, we have a rule that says that the square root of a over b, anytime we got two numbers as a fraction, we can break that up into the square root of a over the square root of b. So we can actually break them up into two different square roots and put one on top of the other as a fraction. And that will help us simplify. Again, you can start this way and move to that way, or move from here over to there, depending on where you start and where you want to get to. So we're given a fraction under a square root here, so I'm going to break it up into the square root of 1 over the square root of 4, and that should make it a lot easier. Square root of 1 is just 1, because 1 times 1 is 1, and the square root of 4 is 2. So we get the square root of 1/4 is 1/2. Let's get a little more complicated here. But really, these two rules will get you most of the way there with irrational square roots. Let's say we got the square root of 3/7. This is where it starts to get tricky here. Well, let's break it up into two fractions. Square root of 3 over the square root of 7. And you might say, well, we broke it up. We can't take the square root of 3, and we can't take the square root of 7. They're already simplified as much as possible. You might think we're done. But as it turns out, we can never have a square root or a radical in the denominator position. Similar to the way we can't have a negative number here, we can't have 0 here. There's a few different things we can't have as denominators. A radical is one of those. We can't have it in the denominator position. So we have to do what's called radicalizing or rationalizing. I call it radicalizing, but I just made it up. It's really called rationalizing. You'll see books say it. Basically what we're doing is we're getting rid of the radical in the denominator position. Well, in order to get rid of a radical, usually just square it, right? Squaring a radical gets rid of that sign. So if we multiply the bottom by itself, the square root of 7, if we just square it, then what we end up with is 7 on the bottom, right? But we can never do something to the denominator without doing it to the numerator when we're dealing with fractions. So we got to multiply the top by the square root of 7 as well. So that process is called rationalizing. So on the top we get the square root of 3 times 7. We're using our rule where we're allowed to make two different radicals. We just combine those numbers under one radical and multiply. So we finally get the square root of 21 over 7. And because we can't simplify 21 any farther, 3 and 7 are really the only factors. We got to leave it as what it is. Sometimes by doing this move you will end up with something on top that you can simplify further. So let's try an example where that happens. I'm just making things up. Maybe it'll work, maybe it won't. Let's do 5. Yeah, square root of 5 over, I don't know, 12. Square root of 12. So we can simplify the bottom a little bit. So let's just rewrite the top as is. We can rewrite this as the square root of 3 times the square root of 4. We're going to take 2 out. So we get 2 times the square root of 3 on the bottom so far. Still have the square root of 5 on top. Let's continue down here. I'm going to rationalize the bottom. I want to get rid of this radical 3 on the bottom there. So I'm going to multiply top and bottom by the square root of 3. And what we get on top is square root of 15. 5 times 3 under 1 radical. And on the bottom we get 2 times, well, square root of 3 times the square root of 3, we could say is the square root of 9, but that just ends up being 3. So that's how that works. And now we got the square root of 15 over 6. So we ended up simplifying something on the bottom a little further instead of the top, which is fine. We could do examples like this all day long. But again, basically there's those two rules. We're allowed to combine two numbers under a radical when we're multiplying and just put them under one radical, or vice versa. And when we have fractions, we're allowed to rewrite those as a radical over another radical. We're just breaking them up, or vice versa, depending on where you start and where you want to go. So that is simplifying rational and irrational square roots. It's going to help us in the next video where I talk about solving a variable using square roots. We're going to get back into quadratics, and we're allowed to solve quadratics. Here's just an intro into it. If we had x squared equals 36, we want to solve for x. Well, if we take the square root of both sides, we get rid of that square, we're left with x. And over on the other side we get a positive 6, but we also get a negative 6. So we rewrite that as plus or minus 6, or positive or negative 6, however you want to say it. And that says that positive 6 squared will give us 36, but also negative 6 squared will also give us 36. And these right here, these quadratics will get way more complicated, and that's what we'll start dealing with in the next video.